Okay, okay, sorry. And admit చేసా మళ్ళీ. Okay. So next topic is integrated development environment, IDE. Okay, this is also the well-known topic, right? And just like our Arduino IDE, okay, 8051 microcontroller IDE like Keel, and 8086 MASM tool, okay, MASM. Okay, all those are the software environments, but they provide the platform for implementation of the coding, compiling, debugging, of course, dumping also. Okay, that is the integrated development environment. Okay, and what actually the IDE is the software platform. Okay, that platform is used for developing and debugging the target processor of a specific embedded firmware. Okay, specific embedded firmware means for each microcontroller or from the different vendors provide different IDEs. Okay, just like our Arduino CC for Arduino CC for microcontroller Keel, for microprocessor MASM, just like that. Okay, processor specific embedded firmware means that. Okay, that individual development environments. Okay, IDE is a software package, right? Which bundles, and just like for suppose when we consider that Arduino CC is the software package, okay, where text editor is there, okay, where you write the code in Arduino C, right? That platform is also called as a source code editor. Okay, after writing, just you have to check for errors. Okay, next we have to do compilation. Okay, see here, so next one is a cross compiler. Okay, cross compiler is suitable for development and compiler for the same platform development. Okay, cross compiler for cross platform. Okay, cross platform means already I told you. Okay, when you write the code in C language, just you have to use C compiler. When you write the code in Java, just you need the Java compiler. Okay, depending upon the different environments, different okay, converters are there and compilers are there. Okay, and for suppose when you write the code in any language, but it is able to convert into machine language, we need one cross compiler. Okay, so the cross compiler for, and of course it is generally independent. Okay, it is able to convert any to machine language. That is a cross compiler. Okay, see here, for cross platform development and compiler for the same platform development. Okay, and any to single same. Okay, linker and debugger. What is meant by linking? That linker, the name itself indicates, it links basic IOs or basic functionalities. Okay, uh, but when we consider the C language, commonly we use hash include stdio.h. Okay, right, where the printf scan of libraries are there. Of course, you need not to include that libraries, but if you are not interested to include that libraries, you must be able to write that libraries also within the code. Okay, in that case, no need of linking that libraries. But because of that uh, IO functions inclusion in that main program, the program becomes very lengthy and complex. Okay, that's why especially uh, IP IP core, okay, IP in embedded systems earlier, and when we develop in 5 volts power supply, which is suitable for many of the applications. Okay, just like here also, uh, input output functions are defined in stdio.h. Okay, hash include stdio.h, right? And after the compilation, okay, that main program you okay links that IO functions into that main program, that links that main program into that library functions, right? That is called a linker. Similarly, debugging is used for already okay. Debugging means of course error checking before that dumping, right? Some IDEs will provide the interface to the target board emulators. Okay, emulator means what is the difference between emulator and simulator? Emulator is always deals with an hardware simulations, and simulator is used for only virtual environment, right? Okay. So some IDEs may provide interface to the target board emulators, target processor controllers, and flash memory programmers, right? Just like our 805 module. Okay. What you do, okay, uh, in MPMC lab earlier, okay, along with some other software development utilities like the version control tool, okay, helpline for development language, and for some it is new, okay, they are able to, okay, they must provide that version control tool and helpline for development language. Okay, IDEs can be either command line based or GUI based. Okay, and for suppose it is a command line, that IDEs may include some GUI support or some helpline, right? Okay, and for suppose you are very new to that environment. Okay, to improve the user friendliness, okay, and to best make use of them at that platform, okay, they are interested to provide some assistance, like, okay, and this is the, okay, and when you want to create your Gmail account, okay, how will they provide some assistance? Okay, enter your register name, okay, enter your name, okay, without starting with numerical. Okay, some suggestions are there. Okay, just like here also, to improve that user friendliness, okay, some helpline for the development language, okay, version control, flexibility. Okay, some of the features are also provided. See here, the IDEs can be either command line or GUI based. Command line, if it is command line based, it may include little or less GUI support. Okay, that is nothing but a command line, okay, just like DOS. Okay, the old version of Turbo C, already you know. Okay, it is best ever of the Turbo C. Okay, okay, why? Because you are in okay, very first year, you started with that platform. Okay, the old version of the Turbo C IDE for the development of applications in C or CPP or CPP for 8086 processor on Windows platform is an example for the generic IDE with the command line interface. Get it? Force the graphical user interface GUI means, okay, based IDE is provided in a visual development environment. Okay, GUI means, okay, graphical user interface. It is for flexibility and especially it is developer flexibility and user development. Okay, such IDs are generally is known as visual IDs. Okay, visual IDs are very helpful in the firmware development. Okay, the typical example for the Visual IDE is the Microsoft Visual Studio developing C language. Okay, Visual CPP already you know. Okay, and Visual Basic programs. Okay, of course, other examples are there. NetBeans and Eclipse. These are the open source softwares for the development of the firmware. Okay, IDEs used in the embedded firmware development are slightly different from generic IDEs. Okay, in their usage and level of language and the development environment and application point of view, right? In a number, especially in the embedded applications, the IDEs is either supplied by the target processor controller manufacturer or third-party vendors as a open source. Okay, when we consider that microprocessor labs, okay, see here, here also they consider the MP lab. MP lab is an IDE tool supplied by the microchip for developing embedded firmware using the PIC family microcontrollers. Okay, same time Keel Microvision 3 from Keel Software is an example of third-party IDE, which is used for developing an embedded firmware of 8051 microcontrollers. Okay, and see here Code Warrior by Metrovox is an example of IDE by IDE for ARM family. Okay, Code Warriors. Of course, we are not using that Code Warriors here. Okay, the updated version of the Kale Microvision 5 is used for ARM family. Okay, in our college. Okay, right. It should be noted that in an embedded firmware development applications, each IDE is designed for a specific family of controllers. Okay, it may not possible to develop a firmware for all family of microcontrollers. Of course, okay, and depending upon the processor architecture and processor family and edge microcontroller family, environments are quite different. Okay, it should be noted that embedded firmware development applications of each IDE is designed for a specific family of controllers or processors, and it may not be possible to develop a firmware for all family using the same IDE. Okay, remember that point. Okay, however, there is a rapid move happening towards that open source IDE, Eclipse, for an embedded system development. Why? Because it is an open source. Okay, most of the processor controller manufacturer and third-party IDEs uh, providers are trying to build an IDE around a popular Eclipse open source. Okay, this may lead to a single IDE based Eclipse for an embedded system and for entire embedded system applications. Okay, in the near future. Okay. Of course, here they primarily focus on the 80515 because for the rapid prototyping and for best understanding. Why? Because already you know that 805 microcontroller architecture features, programming part, and how to write the code and how to dump the code. Okay, and how to develop that particular application with 8051 is best aware. That's why they consider or primarily focus on primarily focus on 8051 based embedded firmware development. The IDE chosen for the demonstration of Keil Microvision 3. Of course, a demo version of the tool for the Microsoft Windows OS based development is available for the free download from the Keil Microsoft website. Of course, Keil 3 is the uh, cracked version is there, okay, but it is having very limited features. Okay, and okay, best example, there is no save option. Okay, please install the same on your machine before proceeding to the next sections. Okay, and already okay, if anybody interested, please okay, install the same, right? Okay, otherwise already I have an installation on Keil Micro 3 Vision. Okay, I will show you everything, right? Okay, okay, after this topic, okay, I create that environment and write the code and okay, simulate that code, okay, okay, for your observation. See here, uh, okay, after this uh, topic I will clearly explain you, or I will see you in the next class, right? See here, Keil Micro 3 Vision ID for 8051. Okay, Keil Microvision 3 is a licensed IDE tool from the Keil Microsoft. See here, there is a licensed IDE tool, not as an open source. Okay, of course, the cracked versions are available from the Keil.com. Okay, Keil Microvision 3 is a licensed IDE tool from Keil Software, ARM company for 8051 microcontroller based embedded firmware development. Okay, of course, it is supports up to ARM 7 only. Okay. To start with IDE, after installing that demo tool, execute the program in Microvision 3. Okay, generally that Microvision 3 is acronymed as UV3.exe. Okay, uh, okay, or see here in bracket they mentioned as the shortcut key Microvision 3 and UV3.exe. Okay, from the desktop, all programs tab from the start menu for host machine with Microsoft Windows operating system. Okay, the ID you shown in figure 13.2 here. See here, it looks here, like this. Okay, so Microvision 3. Okay. It contains a menu bar having a file, edit, view, project, debug, flash, peripherals, and I was. Okay, I will show you everything. Tools, okay, SVCS, Windows, and help. Right. It contains some project window and workspace. Okay, and below that output window is there. Okay, that here the IDE looks very similar to that Microsoft Visual Studio IDE, and it contains a various menu options. The project window showing files, register view, books and functions, and tab and output window. Right, to start the new project, go to the project tab and click on new. Okay, and give a name and save the file. Next, how to create a new project from that new project. Okay, dialog box, and just you have to create that new project. Okay, choose the directory to save the project from the pop-up dialog. Okay, the default extension of the project is .ub2. Okay, .microvision2. Okay, on clicking the save button, okay, you got create a new project. Okay, next, this dialog box lists out all the vendors of 8051 family microcontrollers supported by IDE. Okay, choose the manufacturer of the chip, and I mean, which microcontroller you have to choose. Already you completed the lab on the 8051 microcontroller. Which family you are choosing while implementation of that hardware or software with the 8051. Okay, in Kill Microvision 3 or microprocessor microcontrollers lab, which family you are selected? Intel 8051, right? Or simply otherwise consider 8890C51, right? 8890C51, right? The dialog box lists out all the vendors for 8051 family microcontroller supported by IDE, and we choose the uh, manufacturer of chip of your design. Okay, let it be Atmel. Okay, and 8890C51, 80 means the Atmel. Okay, Atmel itself manufactures the variety of 8051 flavors. Okay, so in our laboratory we consider that Atmel company of 8890C51. Okay, of course 8089S51 is there, 8089C52 is there, S52 is there. Okay, and several recipes, okay, are available in Atmel family. Okay, choose the exact part of the device. Okay, use it for our application. See here, Atmel. Okay, okay, these are the different companies. They provide different microcontrollers. Okay. Among them, you have to choose the required microcontroller. Okay, here they selected Atmel. Okay, from that Atmel company, they select 88C51. C51 is a tool set, and the device name is 88C51, and provided vendor Atmel, right? See here, when I select that 88C51, from that selection, they provide a description. Okay, actually, that 8051 microcontroller contains which type of features. See here, that 8051 based fully static. Okay, that is fully static 24 megahertz CMOS controller. Okay, and what is the clock frequency of that microcontroller is 24 megahertz. Okay, and which type of technology they used? CMOS technology. Okay, that's why that is the fully static 24 megahertz CMOS controller. Okay, see here, 8051 based fully static 24 megahertz CMOS controller. Okay, with how many ports it contains, or how many IO lanes it contains, how many, eh? Okay, how many IO lanes it contains? 32 IO lanes is 32 IO lanes are there, right? Similarly, how many timers it contains? Okay, two timers, timer 0 and timer 1. Okay, timers from counters. Okay, and how many interrupts are there? 6 interrupts. Okay, among the 6 interrupts, okay, how many having highest priority is 2. Okay, two priority levels. Okay, how many UARTs are there? And serial ports. Okay, how many UARTs are there? Okay, uh, 2. Okay, and program memory levels 3. Okay, 4 kilobytes of flash memory, 128 bytes of on chip RAM. Okay, and these are the fundamental features available in that 8851. And when we select the microcontroller, okay, Immediately the description window shows, okay, what are the fundamental features it contains, and is it those features are enough for me or not, okay, to implement an application, right? The same is described here. Okay, listen once. Okay, the dialog box lists out all the vendors of 805 microcontroller supported by IDE. Choose the manufacturer of the chip from your design. Atmel itself manufactures a variety of 8051 flavors already you see. Okay, and choose the exact part of the device. Okay, that is the 889651 we choose, okay, as a target processor for the design. By expanding that vendor node, okay, simply it will list out all supported CPUs by selected vendor under the vendor node. On selecting the target processor, exact part number, the vendor name, device name, tool set supported for the device is displayed on the appropriate fields of the dialog box along with a small description. Okay, that description contains the fundamental features of that processor or controller. Okay, see here the small description of the target processor and the description column on the right side of the pop-up dialog as shown in below figure. Okay, when we press OK to proceed after selecting the target CPU, see here the implemented, they perform the same for 8810C51. Okay, once the target processor is selected, the IDE automatically adds the required startup code for the firmware, and it prompts whether that standard startup code needs to be added to the project. Okay, press F to proceed if you want. Okay, the startup code contains the required default installations like stack pointer setting, initialization, memory clearing, okay, etc. Okay, on cross compiling, the code generated for the startup file is placed on the top of the code generated by the function main. Okay, hence the reset vector 000h always starts the execution startup code before the main code. Okay, for more details on the contents of the code of startup file, please go through the website. Okay, or I will show everything. Okay, simply okay. Uh, okay, and for our convenience and for best understanding, I will install that Kill Micro 3 Vision, okay, in my laptop, and I will share the same, okay, from end to end. See here, the target group with the name target one is automatically generated under files section of the project window. Target one contains a source group with the name source group one, and the startup file of started A51 is kept under this group. Okay, all these groups are generated automatically. If you want to if you want rename that name, okay, yes, we can. Okay, if you want, you can rename these groups by clicking the respective group names. So here you can see the similar Visual Studio IDEs in the project window for Visual CPP development. Okay, that VC++ means VCPP development. Okay, here IDEs project window also contains multiple tabs. Okay, they are the files tabs which gives the file details of the current project. Registers tab gives us the register details. Um, and books tab showing the available help and documentation files supported by the IDE. Okay, functions tabs will list out all the various functions present in that C source file. And finally, templates tab, which generates the automatic code framework. Okay, for if else, switch case, etc, and code documentation template. Okay, these steps create a project workspace. To start the firmware development, we need to create a source file and then add source file to source group. Okay, at the target. Okay, click on the file tab on the menu bar. The IDE select an option new. Okay, a blank text editor will be visible on the IDE's right side of the project window. Okay, starting from that, okay, start writing the code into the in that editor as per the design. Okay, the kill help file using that file supported specific embedded C instructions of 8051 family. Okay, of course. You can write the program in ANSI C or embedded C, whatever it may be. Okay, and general C language also it supports. Of course, general C language, but we have to insert our embedded instructions and some of the features also. That's why that ANSI C becomes that embedded C. Okay, I think ANSI, okay, American National Standard Code, okay, American National Standard interchange. Okay, see here, ANSI and 805 specific codes like port access, bit manipulation instruction. Okay, likewise. Okay, using tail specific embedded C codes. Okay, for using tail specific embedded code, we need to add a specific header file. Okay, that is register reg51.h. Okay, register 51 and 8051 means it means okay is the header file including all the target process specific declarations and 8051 family processors of 8051. Okay, standard C programs calls library routines for accessing IO and they are defined in the stdio file. Okay, the library files cannot use as such files of embedded applications development. Okay, for suppose the IO medium is not a graphic console in the C language based development, right? But if you open that stdio.h file in ANSI C and KL for IDE, you can find implementations of IO related functions entirely. Okay, and all those ports are okay, pictorially represented here. See here, hash include stdio.h into main of void printf hello world. This is the basic C language, right? The difference in implementation of okay, the difference implementation is explained with the typical stdio.h function of printf. Okay, see here, hello world slash n means which is comes under next line. Okay, with ANSI C and DOS, the outputs of the string hello world of the DOS console, whereas C51, whereas with the C51 cross compiler, the same function outputs of the string hello world is to be displayed with the serial port. Okay, coming back to the firmware development, let's follow the universal okay, unwritten law of first C program as a hello world. Okay, see here. The code is written in the text editor which appears within the IDE on selecting a new tab from that file menu. Okay, write the code in C language syntax. Okay, add the necessary header files. You can make use of the standard template files available under templates tab of the project window for adding functions, loops, conditional instructions, etc. for writing the code. Okay, once you are done with the code, save it with an extension of .c in a desired folder. Okay, at the name of the file is sample.ccc. At the moment, save the program with the extension of .c. All the keywords and hash include int, void, etc. Okay, appear in a different color at the title bar of that IDE displays name of the current.c file along with this path. Okay, by now we have created a C source file. Next step is adding created source file to the project. Okay, just to first you have to create the file, next to add the same to that project. For this, right click on the source group from the project window. Okay, and simply add files to the group or source group. Okay, and choose the file sample.c from that file selection dialog box and press add button to the add button and exit the file selection dialog by presenting close button. Now the file is added to the target project. You can see the file in the project window under the files. Okay, instead of this description directly I will show the same here. See here, this is the explanation. Again, what we have discussed so far. Okay, create a new project and create a file and write the code and add that file to that group. That's all. Okay, if you're following the modular programming technique, already you know what is the modular programming technique. Okay, from the concept of CPP. Okay, functions are there. Okay, functions are there for the concurrent execution of that program. Okay, okay, individual modules wise programming is there. Okay, that module wise programming is frequently called as modular programming, right? If you are following a modular programming technique, you may different source files for performing an intended operation. Add all those files to that project as I described above. It should be noted that function main is only a entry point with only .c. Okay, .c file among the files added to the project is allowed to contain the function main. If more than one file contains a function with the same name, with the name okay, with the name main, okay, comparison will be end up if there exists an error. Okay, the next step is configuring the target. Okay, to configure the target, okay, go to the project tab and tab on the menu and select options for the target. Configuration windows are shown like this. See here, atmel 88951 for the frequency of 24 megahertz. Okay, this is called configuration. Okay, this is the target configuration window. It appears like this. Okay, of course, in the next class, I will show that execution procedure and implementation of the 8051 in micro scale vision 3. Okay, so yeah, that's all for today's class. I will continue the same in the next class. Okay, thank you.